Hi guys, are you doing? Today we'll finish our work on all of this stuff, which is linked to the differentiation, limits calculation, and extremor, and all of these one things. And it is investigation of the function topic. Investigation of the function. Or the function. Of the functions, okay. Investigation of the functions. Very often, investigation of the functions refers to the plotting of the graph of the function. I will add here using red ink plotting of the graph of the function. So, firstly, I give you rules or guidance. How can we do it? Or kind of the roadmap. How to make investigation of the function. The first one step, we have to define the range of the function and domain of the variance. So what does it mean here? Here we have exclude all axes when there is no y is f of x. Otherwise, in other words, it means that we have to exclude x's when we can't calculate f of x. A range of the function minimum and maximum values of y. Sometimes people mix these minimum and maximum values of y with extrema of the function. They have different meanings. So-called minimum and maximum is extrema. They are about local maximum and minimum. Okay. The second one here. We have to define points when x's and y's. X's when f of x crosses axis x. It means that we have to define roots of the equation f of x equals 0. The third one points, if we know x's, then function x1, x2, xn. When f of x crosses axis x, we have to define signs or the function within all intervals. of x within intervals of intersection of the x1, x2, within intervals cut by zeros of the function f of x. The first one, we have to define y when f of x cross x is y. X is y. By the way, if some x's some x's don't belong to domain, we have to calculate limits. Then x tends to the xj I put here, xj from the left and from the right side. The sixth one, we have to define extrema of the function. We know that we have to use the necessary condition and the sufficient condition. And the seventh step, we have to calculate f of x when x, they are extreme of the function. Okay, since that we have to go through these 7.7 steps, and then we are ready to make a graph of the function if we can get through each of these operations. Not all of them are really possible. Sometimes we have to drop out some of these steps, and we just can do some of which are possible here. Okay. To define, to make it all of this stuff, we have to make some examples. Investigation of functions, some examples. The easiest one. Investigation of function examples. We'll start from the easiest one. Example 1, y equal x squared for 4 plus 1, for example. Okay, minus 1. The first one step, we have to define domain of this function. Domain. It's clear that we can calculate this function y, the value of y, for whatever x we might take. So it means that domain of function x belongs to the minus infinity up to plus infinity. So it means that x can be whatever we can have whatever value you can image. The second, range of the function, range of the function. When x tends to the infinity, or plus minus infinity, so we can calculate this limit y to y equal, because x can tends to minus can be only plus infinity. For example, if x equals 0, y equal minus 1, and it's clear that y can't be less than 1 minus 1. So it means that range of the function from minus 1, it can be minus 1 when x is 0 plus infinity. So it can be at least minus 1. What else we can see? We can see so-called zeros of the functions, or points when this given function intersect axis x. You can notice that I'm following the given rules. Y equals 0, so x squared minus 1 equals 0, x squared equal 1, x1 equal 1, x2 equal minus 1. Here we have two roots of this equation. It means that function x squared minus 1 intersect axis x in at 2 points, minus 1 and 1. Minus 1 and 1. And by the way, I have to define the sign of this function within all intervals. Between minus 1 and 1, y equal x squared minus 1, positive or negative? It is negative. I use this negative. If x is more than 1, it is positive and positive. So now it's clear that this function looks like this one curve. Now it's very clear. Okay. The first one idea here, we have to define when a function x squared minus 1 intersect axis y. So when x equal 0, y equal 0 squared minus 1, and it is minus 1. So this point here is minus 1. The fifth step. We can calculate extrema of the function. Extrema. To calculate extrema, we have to calculate derivative of x squared minus 1, and it gives 2x. And after this, we have to make equality to x equals 0. So x equals 0. So x equals 0 is extremum, only one extremum of the function. The value at this point y equal minus 1, so it coincides with the intersection with axis y. And now it's clear that it is a minimum point here, because it follows from previous our calculation, but we can check it. And we have something like this. You have to calculate the second derivative, function y, it is 2x derivative, and it gives you 2. It is positive, so it means that point x equal 0, y minus 1 is the minimum of the function. And the seventh step, I didn't say you, but we have also one step here. We can check if it is concave or convex function. Convex or concave function. To check convex or concave function, you have to calculate the second derivative and check its sign. If it is positive, it is what? Convex function, so its slope looks down, and concave, it is then it is negative, uh, the curve is, the slope of the curve looks upward. So here we have, it is positive, so we can, so since that function is convex. This is the investigation of this given function according our rule, according our guidance. Also run example. So the given function is this one. And we have an obligation to define the what? No, to make investigation of this function. The first one step here, domain and range of functions. So, domain of variance. Here we have to know that Ln of x is defined within an interval, within the interval 0 plus infinity. This one restriction define the domain of these functions. So because we can't calculate Ln for negative x's, domain of variance is restricted with the positive part of the real numbers. So it means that domain of variance is from 0 to plus infinity. Okay, next step. We can calculate intersection with, so it's clear that it's impossible to calculate intersection with axis y because when x equals 0, it is the intersection. We can't calculate this function at all. With axis x, ln x minus x equal 0. It is possible only for point when ln x, for points when ln x equal x. Okay. So it means that so we have how to say it. So it's a racial inequality or equality. So I think that we can't calculate the exactly roots of this equation. Okay, and we can skip this. Skip this step. What else we can say? We can calculate limits of the function when x tends to the boundaries of the domain of the variance. Logarithm x limit of the given function when x tends to the 0. What is it? It is minus infinity minus 0. minus infinity minus 0 gives what? Minus infinity minus 0 gives what? Minus 0, minus infinity. Then x tends to the infinity, we have an x infinity minus infinity, but it's kind of uncertainty, and that's why we have to unravel this uncertainty. Okay, so x minus x, when x tends to infinity, it means that is it positive or negative here? So to check is positive, we don't know what is it. Here we have minus infinity minus infinity. It's kind of uncertain. Now we can check. Does x tends to infinity faster than ln x or not? If x tends faster, it's infinity minus infinity. If ln x faster than x, it is plus infinity. To check it, we can make the quotation, the limit of quotation in x over x, then x tends to infinity. When we calculate it, we can use L'Hopital rule, and we have 1 over x over 1, because we can it's equal limit of ln x derivative over x derivative. It is 1 over x over 1. If you put infinity, we have 0. So it means that x tends to the infinity faster than logarithm. So here this minus infinity overcomes the infinity, and we have minus infinity as a result. Sometimes you can use this trick. You can separately define the limits or the quotation or the different terms if you have subtraction of infinities, for example. I don't know. Use 1 over x over 1. And it gives you 0. So it means that this one limit tends to the limit of x minus x, then x tends to the 0, tends to the minus infinity. This is the first part of the investigation of the logarithm. Okay. Okay. So, what should we do next step? Next step, we have to define the maximum and minimum port extrema of this function. Extrema of the function. The fifth step. Extrema on the function. Extrema. To define extrema, we have to calculate derivative of this function f prime of x, f of x prime of x, minus x prime. And we have. So if you have the subtraction, we have to use the rule for subtraction and have calculate derivatives separately. And you have 1 over x minus 1. So this point gives you the extrema of the point, extrema of the function. If we make this equality, we have that 1 over x equal 1 and x equal 1 gives the extremum of this function. It has only 1. And the sixth, and here we have to use the sufficient condition and calculate the second derivative. The second derivative of the function. We calculated the first one. 1 over x gives minus 1 over x squared, 1, 0. And so this is the second derivative, and now we have to check its sign at the x0 point. Sign of the second derivative, it is 1 over 1 squared minus 1, it is negative. Negative, since that this point x0 minus or equal 1, it is function has maximum. F of x, f of 1 is a maximum of the function. And we have to calculate this value. Y equal ln x ln 1 minus 1. We know that it is 0. You can use your calculators, and it is minus 1, so it is the maximum point has coordinates 1 minus 1. And the last one step here, we can define if it is concave or convex function. To define if it is convex or concave function, we have to define the sign of this, the second derivative. Sign of the second derivative, which is minus 1 over x squared. It is what? It's always negative. And if it is negative, it is what? Convex or concave function? Concave function, so its slope looks up. A concave function. So they finish our investigation. Now we are ready to plot this graph. So I don't have here enough room. So if you don't mind, I want mind the cleaning of this part of this whiteboard picture, and I use this place here, this on extreme part. How does it look? So I have here XY coordinate system. XY. We remember that when x tends to 0, limit of the function tends to minus infinity. When x tends to the infinity, y tends to the not 0 minus infinity, minus infinity. So it looks like here. We have the extreme point x0 equal 1. The value of function at this point is minus 1. And it is kind of the maximum of this point. And this point is always concave function, so it looks according to this one logic kind of this curve. So this is schematic view, a schematic view with the function y equal lnx minus x. Bye bye.